Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class, we are going to discuss a numerical on the topic analysis of perfect frames by using method of sections. The same numerical we solved already by using method of joints. That video link is given in the description box of this video. Okay. If you want to see that video for the reference, you can go to the description box. There will be the link in which the same numerical was solved by using method of joints that you can see. So here, this numerical we are going to solve by using method of sections. The figure shows a frame of 4-meter span and 1.5-meter height subjected to 2-point loads at B and D. Find the forces in all the members of the structure. Okay. So here there is a frame is given. Here the span length 4-meter, and then there are 2-point loads. At point B, there is a horizontal load 8 kilonewton. At point D, there is a downward force 12 kilonewton. Okay. Here you can see it is supported at the two ends, point A and point C. At point A, it is a hinged support. But at point C, it is a roller support. When you have horizontal loading or incline loading, if it is incline, that we have to resolve into two components, horizontal and vertical. So if it is incline also, you have the horizontal loads. Okay. So roller support with horizontal or incline load, you have to consider the horizontal reaction also in the hinged support. Okay. So here you can see, first I'm going to draw the supports, that means support reactions. Here at point A, you know that there will be an upward reaction force or A that will act. Okay. And from point A, here you can see 8 kilonewton horizontal load is there. Here there is no other horizontal force. So this 8 kilonewton, it is acting towards right side. So from point A towards left side, the horizontal reaction HA that will act. Upward reaction RA, horizontal reaction towards left side HA. Okay. At point C, as usual, an upward reaction RC. So now there are three reactions are there. First here, we have to calculate the reaction. Okay. First of all, this is method of sections. Okay. In method of joints, we will solve by using algebraic sum of the vertical forces 0 and algebraic sum of the horizontal forces equals 0. In method of sections, we use the third one, that is algebraic sum of the moment about any point equals 0. We will consider the section line, then we will calculate moment about the points, then we will find the forces in the member. First thing, reaction calculations. Okay. In reaction calculations, generally, we will use all the three principles. Okay. Here, three principles of equilibrium. Mostly summation of vertical equals 0, summation of moment equals 0. But here there is a horizontal force is also there. So we have to use algebraic sum of the horizontal forces equal to 0. That also we have to consider. 8 kilonewton, that is towards right side. To compensate that, a horizontal reaction is acting at point A towards left side. So this left side reaction force that equal to the right side point load. So the horizontal reaction HA towards the left side that equal to 8 kilonewton, which is acting towards right side. Okay. This left side force, this right side force. This is the first equation. Then algebraic sum of the vertical forces equal to 0. Here, there are two vertical upward forces are there, RA, RB, and one downward force, that is 12 kilonewton. So the addition of the upward forces, RA plus RC, that equal to 12 kilonewton. This is the second equation. Then, third principle of equilibrium. Take moment about any point equal to 0. Here, take moment about the point A. And that should be equal to 0, since if the truss or this frame is in equilibrium, each joint should be in equilibrium. Okay. So when you take moment about A that equal to 0, here we know that this 12 kilonewton multiplied by 2, the 12 into 2, that will be in clockwise. So 12 multiplied with 2. This is in clockwise direction. Then this 8, okay, it is acting this direction. Here you can see from the point A, this will be the perpendicular distance, because this is the line of action of point 8. This one will be the perpendicular distance, which is equal to BD. That value is given 1.5. Okay, that value is given 1.5. So 8 kilonewton into BD with respect to point A, that is also in clockwise direction. This 8 into this distance, that is also in clockwise. So that will be added the same side. 8 multiplied with the distance 1.5. This is also clockwise. So these two will be balanced by the counterclockwise moment, which is made by the vertical upward force at point C, that is RC. From the point A, the distance is 4. So that equal to RC multiplied by 4. So when you simplify, we will get the value of RC that equal to 9 kilonewton. When you substitute the value of RC in equation 2, then RA plus RC equal to 12. So RA equal 12 minus 9. So we will get 3 kilonewton. Okay. So RC, RA, both the values we had found. Then we are going to calculate the angle theta, because here there are two inclined members are there, like AB and BC. So by using method of joint or method of section, we will resolve this into two components, sin theta, cos theta, like that. So we need this angle theta. And here you can see this BD, that is 1.5. This AD and CD, both are 2 meters each. So if this is theta, this angle also theta. Okay. So that angle theta made by these two inclined members, AB and BD, with respect to the horizontal, that we are going to find. Okay. In this right angle triangle, ADB, the triangle ADB, we know the value of opposite side 1.5 meter, then the adjacent side 2 meter for the angle. So we can take tan theta that equal to the opposite side BD by AD. Here we know the value of BD, that is 1.5. The horizontal value, that is 2. So if you divide, you will get 3 by 4. So the theta equal tan inverse of 3 by 4. So we will get the value of theta 36.9 degree. So the theta is 36.9 degree. This is the inclination made by both the inclined members, AB and BC, with respect to the horizontal. Okay. Now, the method of sections. First, I am going to consider the section line 1, 1. Here, I am considering the section line 1, 1. It passes through the member BC, BD, and also AD. Okay. So here, it separates the entire frame into two segments. Like we can take left side portion and right side portion. We can consider any one of the portion. Here, I am going to consider the left side portion. That means what are all the members and forces in the left side to the section line that we have to consider. Here you can see AB, it's a whole member. It is at the left side and it is not passes through the, that means the section line is not passes through the member AB. So it is a whole member. So the force we don't want to consider. The forces in the member BD, forces in the member BC, and forces in the member AD. These three we have to consider. And apart from this, the point loads, that is 8 kilonewton, that is acting at point B. These two reactions, RA and HA. Okay, these 6 forces we have to consider. Okay, here we consider the section line 1, 1, and it separates the entire diagram into two segments. Here, any one side we can consider. So here we are going to consider the left side portion of the section line 1, 1. So here, 3 members, that means forces in 3 members, BD, BC, and AD. Here guys, AB is a whole member and the section line is not passes through that. So that force we will not consider. Okay. And then the point loads, which are all outside the considered portion, such as 12 kilonewton or C. These two things we don't want to consider. Okay. Point loads, which are all outside the considered portion, that we are not going to consider. The members such as AB, which is even though in the considered portion, but not cut by the section line, that forces in that particular member also we won't consider. Okay. Then what are the things we will consider? The forces in the member in which the section line passes through it, like BC, BD, and AD. And the point loads in the considered portions, 8 kilonewton, RA, and HA, since we are considering the left side portion of the section line 1, 1. Okay. So now, taking moment about the various points, we are going to calculate the values of the forces in the member. So first, here we are considering the section line 1, 1. Okay, section line 1, 1. First, I am going to take moment about B, and that should be equal to 0. When I take moment about B, the forces like this 8 kilonewton, this is forces in the member, this one, TBD, this inclined one, that is TBC, this one, TAD. Okay. So when I take moment about A, all these three forces, 8 kilonewton, TBD, TBC, that will be eliminated because all the three forces are acting at point B. So here for these three forces, we can't get the perpendicular distance from the point B. So moment due to these three forces will be eliminated. So here totally 6 forces in the considered portion. When these three forces are eliminated, moment due to the remain three forces we have to consider. For an example, RA. Here you can see RA is an upward force. It is acting like this in this line we can take. And from the point B, this will be the perpendicular distance. That means which is equal to AD, which is equal to 2 meter. So we can take this RA. Okay, RA is an upward force multiplied with 2. With respect to B, the RA and multiplied with B. Okay, RA and B, that will be in clockwise direction. Okay, RA and multiplied with B, that will be in clockwise direction. So RA multiplied with 3, clockwise moment. This HA, we know that the HA passes through point A, point D, point C, like that we can take. So if this HA, if you consider passes through point D also, then from the point B, the perpendicular distance will be BD, which is equal to 1.5 meter. And from the point B, this HA multiplied with the perpendicular distance, that is also will be in clockwise direction. Okay, which will be added on the same side. So the value HA multiplied with the vertical distance 1.5. This is also in clockwise. So here I told already among 6 forces, moment due to 3 are eliminated, moment due to the other 2 forces calculated. But these 2 are in clockwise, so only one force is there. So the moment due to that remaining one force, that should be in counterclockwise, then only that can cancel the addition of the moment due to these 2 forces in the clockwise direction. So that should be in counterclockwise direction. That is TAD. Here you can see that TAD is a horizontal force. So with respect to the point B, that means as usual, we can say this may act like this. Okay. Or otherwise in opposite direction. That means like this. Here you can see if it is acting in the same direction of HA like this, then with respect to B, this force multiplied with the 1.5, that also will be in clockwise. So to compensate the clockwise moments, it should act opposite to the direction of HA. That means like this. Do you understand? So from the point B, if you have taken the moment, this TAD multiplied with 1.5, that should be in counterclockwise. Okay, that should be in counterclockwise. So TAD multiplied with 1.5, that is the perpendicular distance. This is counterclockwise moment. So here RA, that value also we know, HA also we know, and the value of TAD. Okay, everything we know. That means RA. Here you can see that will be 3 kilonewton. RC, that is 9 kilonewton. HA, that we know that equal to 8 kilonewton. Okay, so if you substitute the values of RA and HA, then when you calculate the value of TAD, okay, so we will get 12 kilonewton. Here you can see from the point A, it is going outward. So from the point D also, it will go. That means same direction outside. Do you understand? So that will be compressive in nature. Do you understand? This is then compressive in nature. Okay. Then I am going to take moment about another point. That means moment about the point D. Okay. Moment about the point D and equate to 0. Okay. When I take moment about the point D and equate to 0. Here you can see when I take moment about D, this TAD that is passes through the point D, HA that also passes through the point D, this TBD that is also passes through the point D. Do you understand? HA, TAD, TBD, because the TBD it may be upward or downward, whatever it is, the line of action of that force passes through the point D where we are going to calculate the moment. TAD, it's directly passes through it. HA, that also we can consider A, D, C like that. Okay. So moment made by HA, TAD, TBD will be eliminated. So the moment made by the three forces among 6 are eliminated. So moment made by the other three forces we are going to consider. With respect to the point D, here you can see this is 8 kilonewton. The perpendicular distance BD that is given 1.5 meter. So 8 into 1.5. Okay, 8 into 1.5. That will be in clockwise direction. Okay, so 8 multiplied with 1.5, that is clockwise direction. And then another force RA. From the point D, RA is an upward force. It is acting the perpendicular distance 2 meter from the considered point D. So RA multiplied with the distance 2. Okay, RA multiplied with the distance 2, that also in clockwise direction. So plus RA. The value of RA we know that is 3. So RA multiplied with the distance 2. This is also in clockwise. So the moment made by the remaining force, that is an inclined force, TBC, that should be in counterclockwise to balance this moment. Here you can see the TBC, it's an inclined force. There are two possibilities are there. In case, if it acts inwards to the B, so we will resolve two component. This will be TBC sine 60 and the horizontal, that will be TBC cos 60. Okay. This will be TBC sine 60, the vertical value, and this will be TBC cos 60. Whatever the TBC sine 60, that will be passes through the point D, then that will be eliminated. So only horizontal component. If it acts towards left side, okay, that means if this TBC cos 60 is acting towards this side, multiplied with the value vertical distance 1.5, then we will get counterclockwise moment. Okay, so for point B, it should act inwards to the BC. Do you understand? That should act inwards to the BC. Okay, so here I just write the datas. Okay, TBC. If the TBC is this direction, okay, TBC is this direction, then the vertical component will be eliminated, but the horizontal component of it, that is TBC cos theta, that will act towards this side. So TBC cos theta multiplied with the distance 1.5, that will be in counterclockwise. So TBC cos theta multiplied with 1.5, the vertical distance. So here the theta value we know 36.9, and if you substitute all the values and by simplifying, we will get the value of TBC, okay, that equal to 15 kilonewton. And for the point B, it is acting inwards. So for the point C also, that will act inwards. So that will be tensile in nature. Okay, that is tensile in nature. Okay, so as of now, we calculated forces in two members. Then the remain forces also we are going to calculate. Then taking moment about the point C and equal to 0. When I take moment about C, here you can see in the considered portion, 6 forces are there. This TAD that passes through the point C, consider reference point C. HA, that is a horizontal force. HA horizontal force, TAD horizontal force. So both the lines passes through D and also C. So HA, TAD, moment due to the two horizontal forces eliminated. Okay, HA, TAD eliminated. TBC, it is an inclined force. That line also passes through the point B and C. So the moment made by that force, TBC, that also eliminated. So HA, TAD, TBC, moment due to these three forces eliminated. Moment due to other three forces, 8 kilonewton, RA, and TBD. This we have to consider. So when you take moment about C, this is 8 kilonewton. Do you understand? That means you can see this is the line of action. Then the perpendicular distance. Do you understand? That is this 8 kilonewton, we can consider point B along this line or like this. Okay. Like this we can consider. The perpendicular distance from the point C, that will be 1.5. So 8 into 1.5 with respect to C, that will be in clockwise direction. So 8 into 1.5, this is in clockwise direction. Then this RA, it is an upward force and the perpendicular distance from C is 4 meter. RA into 4. This is also in clockwise direction. RA into 4. That also in clockwise. So will be added in the same direction. RA multiplied with 4. This is also clockwise. So this should be balanced by the another counterclockwise moment. Here only one force is TBD. It may act upward or downward. If it is acting upward, this TBD and the perpendicular distance 2 meter from C, okay, that also will be in clockwise. So it will not act in upward direction, but that should act in downward direction. Okay, if it is downward, then this angle 2, sorry, distance 2 from the point C. So TBD into 2, okay, that will be in counterclockwise direction. Okay, so TBD multiplied with 2, that will be in counterclockwise direction. We know the value of RA, 3 kilonewton, substitute, and by simplifying, we will get the value of TBD, that equal to 12 kilonewton. And then here you can see from the point B, it moves outward. So from point D also, it will be outwards. So you know that this will be compressive in nature. Okay, so that is compression. So 3 forces we calculated. So remain 2 forces we have to calculate. So that we can't do by using the section line. The same section line 1, 1. Because the member AB is not cut by the section line 1, 1. Same CD, that is also not cut by the section line 1, 1. So we got to draw another one section line 2, 2 that should pass us through the required members AB and CD. Okay, so that now we are going to do. Now I am going to consider the section line 2, 2, which passes through the required members AB, CD, and also the member BD. A section line can pass through maximum 3 members. If it passes through, if you consider the section line passes through more than 3 members, then the calculations will be tedious. Okay. So here it is passes through only 3 members. As usual, this section line separates the frame into 2 segments, like upper part and lower part. Any one we can consider. Here I am going to consider the upper part. That is the force in the member BA or AB. The force in the member BD. That BD already we calculated. Okay. Then the whole member BC. Okay. So here the section line does not cut the member BC. So the forces in the member BC we will not consider. Then force in the member CD. So here there are 3 forces in the member, such as T, BA or TAB. This one, okay, that is TAB. This one, TBD. But actually, this diagram, that means this magnitude wise, we calculated magnitude and direction. Guys, BC is a whole member. It does not cut by the section line. So we will not consider the forces in that particular member, even though it is present in the considered portion. Okay, the whole member, the forces we won't consider. Then this one, CD, tension in the member CD. Here, AB and CD, these 2 forces we have to calculate. Okay, and if upper portion is the considered part, all the point loads in the considered portion you have to consider, like 8 kilonewton and the RC. So there are 5 forces are there. 2 point load, 8 kilonewton, reaction upward force RC at point C, TAB, TBD, TCD. TBD already we calculated. So TAB, TCD we are going to calculate. The point loads 12 kilonewton, these 2 reactions are not in the considered portion. So that we won't consider. Okay. So now the section line 2, 2. And we are going to consider the upper half. Okay. That is upper portion of the segment that we are going to consider. Okay, first I am going to take moment about C and that equal to 0. Here you can see when I take moment about C, the force, actually I told there are 5 forces are there, 8 kilonewton, TAB, TBD, TCD and RC. When I take moment about C, this TCD, it is a horizontal force. That line passes through the point C and upward force RC exactly acting at point C. So moment made by these 2 will be eliminated. Okay. Then the remaining 3 forces, that is moment due to the 3 forces we have to consider. You know that 8 kilonewton. Okay. Do you understand? That means this 8 kilonewton multiplied with 1.5. Okay, so 8 multiplied with 1.5, that is in clockwise direction. Okay, so 8 multiplied with 1.5, this is clockwise moment. Then the TBD. Okay, so TBD multiplied with this perpendicular distance 2 meter, TBD 2. This is actually downward. So this will be in counterclockwise. That I am going to substitute here. That is 2 that is TBD, the perpendicular force TBD multiplied with 2. This is in counterclockwise. Okay. Then the another force is TAB. Here you can see the TAB is an inclined force. We can consider the line passes through this one. It may act this direction or otherwise this direction. But whatever, the horizontal component will passes through the same C. So the horizontal component we won't consider here. From the point A, only the vertical component, that is TAB sine theta. The TAB sine theta and multiplied with 4 meter. Okay, that should be, here you can see the value of TBD, that is 12 kilonewton. If you substitute 12 here, 12 into 2, that will be 24. But 8 into 1.5, that means here you can see the clockwise, that is this side 12 and this one, that is actually 24. So here you see this counterclockwise is more. So whatever I am going to add, that I have to add in the clockwise direction, that is on the left hand side. So the moment made by the TAB, that should be in clockwise direction. Here, if it acts upward, then the vertical component also upward. Guys, the horizontal component TAB cos theta, that will be like this. And that passes through the point C. So when you take moment about C, that will be eliminated. Okay, so TAB cos theta, we are not going to consider. So only the vertical component, that is TAB sine theta, upward force, and the distance is 4, and this will be in clockwise. That have to be added on the LHS side. Do you understand? That should be added on LHS side. Since this is 12, this is 24. Here counterclockwise is more than the clockwise. So moment made by the TAB sine theta multiplied with 4, that should be added on left hand side. Okay, so I'm going to add that value on left hand side, plus 8 into 1.5, that value, plus TAB sine theta multiplied with the value 4. Okay, so if you simplify this, everything is equal to this right hand side value. Okay, this 2 you have to add, that equal to this right hand side value. The TBD already we know, substitute it here. So from this, you can get the value of TAB, that equal to 5 kilonewton. Okay, and then here you can see for the point A, it is acting inward, sorry, point B. So for point A also, it will be inward. So that will be tensile in nature. Do you understand? That is tensile in nature. Then the only member, that is TCD, we have to calculate. So I am going to take moment about the point B. Okay, so I'm going to take the moment about the point B, and that equal to 0. So here, when I take moment about B, 8 kilonewton, this tension in the member AB, tension in the member BD, these three are acting exactly at point B. So the moment made by 8 TAB, TBD, that will be eliminated. So the other two RC, here you can see this is the direction of RC. Okay, and this distance, that is 2 meter. This is the direction of RC, 2. So this RC into 2, that will be in counterclockwise direction. RC multiplied with 2. Okay, so RC multiplied with 2, that is counterclockwise direction. This should be balanced by the moment made by the TCD. Here TCD, there are two possibilities. It may act left side or right side. But whatever, here you can see, you can consider this is acting like this. So from the point B, that will be in a perpendicular distance 1.5 meter. If it acts to inwards to the C, that is towards the right side, then the moment made by TCD also counterclockwise. Okay, moment made by TCD also counterclockwise with respect to B. Okay, so it will not act towards right side because we need a clockwise moment. So it will act outwards from the point C. So from point D, it will be this side. So from point B towards left side. So TCD multiplied with 1.5. Okay, that is TCD multiplied with 1.5. So here, this will be the clockwise moment. So if you substitute the value of RC, 9 kilonewton, then the TCD, okay, that equal to 12 kilonewton. Okay. So here, this TCD, from the point C, it is acting outward. So from point D also outward. So this will be compressive in nature. That is compression. Now all the required values we calculated. Finally, the force table. We are going to tabulate all the results. First one, serial number, then members, then magnitude of the forces in the members in terms of kilonewton, then nature of the forces, either tensile or compressive. First one, that is AB. The magnitude we calculated 5 kilonewton and it is tensile in nature. That is tension. The point 2, that is the member AD, that we calculated 12 kilonewton, and here you can see AD, that is compressive in nature. So compression. Third one, the forces in the member BC. Numerically, we calculated 15 kilonewton. And here you can see the value of BC. This one, that is tensile in nature. Okay, so tension. Then the fourth one, that is CD. Numerically, we found the value of CD 12 kilonewton. Here CD, that is also compressive in nature. So compression. Then the fifth one, that is BD. Numerically, we found the value 12 kilonewton and that is compression. 12 kilonewton, and then that will be compressive in nature. That is compression. Okay. So I hope you all understand this numerical. Actually, guys, this is part 2. We solved by using method of sections. The same numerical we solved by using method of joint. That video link I had given in the description box. So it's better you just watch both the videos for clear understanding. Okay. So to watch more videos on engineering mechanics and then these topics, method of joint, method of sections, etc., don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Okay. Thank you, guys. Thanks for watching.